All right, we are going to be multiplying with scientific notation today, and hopefully you guys figured out from prior lessons that scientific notation is a really great way to write really large or really small numbers more efficiently. So in this case, we have these two numbers, 32 billion times 123 million. Those are two really large numbers. If I want to multiply those, then an easy way to do it would be to use scientific notation, okay? So what I'm going to do is I'm going to rewrite both of these numbers in scientific notation. So 32 billion is 3.2 times 10 to the 10th power. I had to move my decimal 10 places to get it between the 3 and the 2. And 123 million is 1.23 times 10 to the 8th power. Okay? So now remember, multiplication is commutative. I can multiply in any order. So I'm going to rewrite this as 3.2 times 1.23 and 10 to the 10th times 10 to the 8th, okay? Now I'm going to use my calculator to do 3.2 times 1.23 because, you know, everybody would. And 3.2 times 1.23, I get 3.936. So I have 3.936 times 10. Remember, when we're multiplying powers that have the same base, we just add their exponents. So 10 to the 10th times 10 to the 8th becomes 10 to the 18th power. Okay, and that would be our answer. Okay, let's try another one.
And another one.
All right, so here we have 4.2 times 10 to the 7th times 5.1 times 10 to the 5th. So again, we're going to start by rewriting this. We're going to group our 4.2 and our 5.1. Remember, multiplication is also associative. We can regroup multiplying in any order. And we have 10 to the 7th times 10 to the 5th. Okay, so 4.2 times 5.1, 4.2 times 5.1, we get 21.42. 21.42 times 10, well, 10 to the 7th times 10 to the 5th is 10 to the 12th. 7 plus 5 is 12. Well, we get this answer, and it looks scientific notation-ish, but it's not. Remember, scientific notation has to have a ones digit and then anything after the ones digit listed as decimal. So 21.42 has a tens digit. We're going to rewrite that. We're going to change that to say 2.142 times 10 to the first power. That's what 21.42 is. It's 2.142 times 10 to the first. And then times 10 to the 12th gives us 2.142 times 10 to the 13th power. And that would be our answer. Okay, that's in scientific notation. Okay, so that was with really big numbers. The same thing applies to when we're writing answers in scientific notation for really small numbers. First thing we're going to do is turn these two really small numbers into scientific notation. And so to do that, I'm going to have 1.23, 1, 2, 3, 4, 5, 6, 7 times 10 to the negative 7th power. and 3.0, or simply 3, times 10 to the 1, 2, 3, 4, 5, 6, negative 6th power. Okay, so 3 times 1.23, I'm going to rewrite that. 1.23 times 3.0 times 10 to the negative 7th times 10 to the negative 6th. Okay, so 3 times 1.23 is 3.69 times 10 to the negative 13th power. Okay, so that's how it works with really small numbers. That's a ridiculously small number. Okay, so what if the numbers aren't in scientific notation, or maybe one of them is and one of them isn't? For example, 80 times 3.2 times 10 to the negative 6. Well, we could do the same thing. We could turn 80 into 8 times 3.2, or 8 times 10 to the first times 3.2 times 10 to the negative 6. Or I could just regroup it like this. This is what I'm going to look at here. Do it a little differently. I'm going to look at 80 times 3.2 times 10 to the negative 6. Okay, so all I did was regroup there. So 80 times 3.2, 80 times 3.2 is 256. So I have 256 times 10 to the negative 6. Well, 256 is 2.56 times 10 to the second power, right? Moving our decimal 2 places. And then times 10 to the negative 6th. So our final answer here in scientific notation would be 2.56 times 10 to the negative 4th power. All right.
Bazinga! Bazinga! Bazinga!
Got a little carried away with the bazingas. All right, we're looking at a word problem because you guys love the word problems. The speed of light is about 3.0 times 10 to the 5th kilometers per second. Use the distance formula. D equals R times T to find the distance light travels in an hour, which is 3.6 times 10 to the 3rd seconds. 1 hour is 3.6 times 10 to the 3rd seconds. That's 3,600 seconds. All right, so our distance is equal to 3.0 times 10 to the 5th times 3.6 times 10 to the 3rd. Okay, that's going to give us the distance it travels in an hour, because that's how many seconds there are in an hour. Okay, so we're going to do 3.0 times 3.6 times 10 to the 5th times 10 to the 3rd. Okay, 3.0 times 3.6 is 10.8. Remember that, we're going to have to change that. 10.8 times 10 to the, well, that's 5 plus 3 is 8, so 10 to the 8th power. Now remember, 10.8 isn't scientific notation. We have to make that 1.08 times 10 to the 1st times 10 to the 8th, which is 1.08 times 10 to the 9th. 1.8 times 10 to the 9th. What? 1.8 times 10 to the 9th kilometers. Okay. And this is our last one. Let's try this. Yosemite National Park covers 7.6 times 10 to the 5th acres. They're about 4.36 times 10 to the 4th square feet in 1 acre. How many square feet does the national park cover? Okay, so how many feet is 7.6 times 10 to the 5th times 4.36 times 10 to the 4th? That's the question. Okay, so 7.6 times 4.36 and 10 to the 5th times 10 to the 4th. All right. Oh, no. Okay, let's try this. Hopefully that's still going fine, because that was weird. 7.6 times 4.36 is 33.136 times 10 to the 9th. Well, that's not scientific notation. So that's going to be 3.3136 times 10 to the 1st times 10 to the 9th. Hopefully you guys just picked up that you could really just add another value to the exponent. So we have 3.3136 times 10 to the 10th power. Feet, square feet. All right. So that is multiplying with scientific notation. We're going to do IXL G3, and we're going to go to a SMART score of 85. Okay, so that's what the goal is. SMART score 85. And hopefully this video was okay for you. Still working out the bugs on how to get this stuff to go. But I'm hoping this is helpful. All right. Talk to you guys later.